Welcome class, myself Professor D.S. Rai, Professor Department of Civil Engineering, BBD, ITM, Lucknow. We will take up a course KCE 076 Urban Transportation Planning. Today we will take up lecture 19, in which we will discuss trip generation. References that we have taken: Chakravarti Partho and Das Animes, Principle of Transportation Engineering, Papacosta and Prevendas, Transportation Engineering and Planning, Kadiali and Lal, Principle and Practices of Highway Engineering, Naptel, and some material have been taken from internet. The topic or content today we will discuss: type of trip generation modeling, multiple regression analysis, stepwise approaches, cross classification analysis. Type of trip generation modeling. First of all, why we are taking this model? In any urban area, we have certain data, we can say present data, and we have to analyze this data for the future plan. So, these all models are taken for the future. So, the trip generation can be modeled using the following. One is called multiple regression analysis, and second is cross classification, or sometimes it is called category analysis. In multiple regression analysis, a mathematical relationship is developed between the trip generation and the influencing variables. In the category analysis, different categories are created and trips rates are estimated for each category. Selection of a method depend upon context and resource availability. The majority of trip generation studies performed to date have used a multiple linear regression analysis to develop the prediction equation or the model for the trip generated by various type of land use. In any type of model, the land use is very important in the urban area. Land use means land pattern, how we are using. Multiple regression analysis is based on trip generation as a function of one or more independent variables. The approach is mathematical and all of these variables are considered random and with the normal distribution. As we know, normal distribution is like this is the normal distribution curve. So, the approach is normal distribution. Example of regression equation for trip generation: here Ti, this is the trip generation in zone I. That will be equal to 0.45 Pi plus 0.14 Ai. and for attraction Aj will equal to 68.7 plus 0.86 Ej, where Ti is equal to total number of trip produced in zone I, and Aj is the total number of trip attracted in to zone J. Pi is the total number of population in zone I, and Aj the total number of automobile in zone J. Fe is total employment in zone J. In multiple regression analysis for a trip generation, first data regarding the actual number of production and attraction in coupled with the data about the area that is thought to impact the production and attraction. Then an attempt is made to develop a relationship between these parameters using a statistical regression. Once an acceptable and satisfactory relationship is obtained, the same is used for estimating future production and attraction. Then we come with the stepwise approach. Step 1, examine the relationship between the dependent variables and each of the independent variables in term in order to detect non-linearity. If non-linearity are detected, the relationship must be linearized by transforming the dependent variables, and the independent variable are both. Most computer regression analysis programs have a number of options for linearizing data sets before a regression analysis is performed. Now, come to the step 2, examine the sample correlation matrix in order to detect those independent variables which have a statistical association with the dependent variables and the potential resources of collinearity between the pairs of the independent variables. The simple correlation matrix are made. Let us consider that the variables are correlated if the value of r is more than 0, more than 0.7 in the above example. X 1 and X 3 have a very high degree of association with the dependent variables with r value of 0.827 and 0.084 respectively. The simple correlation matrix also indicates a high degree of association with x 1 and x 2, x 3 and x 5. X 1 and x 2 and x 3 and x 5 are largely measures of the same variables, and so they should not be included in the same regression analysis. So, in this problem the analyst has the option of the following regression analysis. We can see here y is equal to a plus b x 1. Here the variables are only one x 1. Y is equal to a plus b into x 3. Some other variables. Then y is equal to a plus b 1 x 1 plus b 2 x 3. Here variables are 2. Now, y is equal to a plus b 1 x 1 plus b 2 x 3 plus b 3 x 4. So, here the variables are 3. So, one of the important factor is we take the model which has lesser number of variables. Now, come to the step 3. Estimate the parameters of each of the potential regression equation and investigate the following. What is the magnitude of R square? First, do the partial regression coefficient have correct sign and are their magnitude reasonable? Third, are the partial regression coefficient statistically significant? Is the magnitude of A reasonable? So, we can go, the 4 equations were fitted to the data with following results. A standard error of estimate SSE, that is 570.4, R square coefficient of determination 0.68, t value of regression coefficient 9.08, a standard error of estimate SSE 542.93, the R 2 coefficient of multiple determination 0.74, t value of regression coefficient 9.75. So, y is equal to 894.5 plus 0.66 x 1, y is equal to 444.39 plus 1.045 x 3. Here x 3 is the population, x 2 number of household, x 3 vehicle ownership, x 4 distance from central business district, x 5 income, y peak hour trip produce. The method is applicable for trip production and trip attraction both. Trip rates are considered relatively stable over time for a certain stratifications. The trip rates are obtained empirically requiring a large amount of data. A separate model structure are recommended for trip production and trip attraction. The trip rates per household is related to various household characteristics such as income, car ownership, household size, etc. Now, come to the cross classification analysis. An example of trip production model structure with the household trip rates, cross classified income or car ownership. Cross classification analysis Zonal trip production may be estimated as P I is equal to sum over C B I in bracket C T P in bracket C, where P I is the number of trip produced in zone I, H I C the number of household in zone I in category C. Here C means the category, C categories. TPC the trip production rate of household category C. Trip attraction in contrast to trip production modeling, which focuses on household characteristic. Activities might be related to stores, offices, factories, etc. The number of trip attracted to a certain activities is related to a measure of the amount of the activities. An example of trip attraction model structure with trip rates cross classified by a trip of retail employment and a trip. Non retail employment, downtown retail employment, other retail employment, home based work, home based other, non home based etc. The zonal trip attraction may be estimated as A j is equal to sum over B j in category C, T A in category C, where A j is the number of work trip attracted by zone J, B j in category C is equal to the number of employment opportunity in category C, T A in category C is equal to trip attraction rate of employment in category C. So, in this way we can form the group, we can make a group of a different data. Now, come to the model calibration. In model calibration, the relationship between the travel and the variable influencing travel are quantified. Developing trip production rates. Consider the development of trip per household as stratified by a car ownership and income is an example. Now, we come for second step, that is a trip distribution. Trip distribution, two known set of trip ends are connected together to form a strip matrix between known origin and destination. Trip distribution may be carried out with or without specifying the actual route and or travel mode. the number of trip is estimated for a particular period of time, average weekend or a peak hour. We can see here, this is a zone I. This is zone I. Here the number of trips are generated, and this is a zone J, where number of trips are attracted. So, we can see here, this is the a trip distribution model. Here is we can see here, this is the zone I and this is J. This is for production or origin and this is destination. This is zone 1, 2, 3, 4 and this is the summation. This is zone 1, 2, 3, 4 and the total. So, here the number of trips in zone 1 to zone 1, this will be T11. Zone 1 to zone 2 means there are attraction in zone 2. So, this will be T12. Like zone 3, 1 to 3. So, T13 means some trips are attracted in zone 3, like zone 4, T14 and so on. Now, come to the zone 4. So, the from zone 4 to 1, this will be T41 and likewise T42, T43, T44 and summation of these all attraction T11 plus T12 plus T13 plus T14, that will be equal to P1 and likewise P2, P3, P4 and the summation of these all is a total number of trips generated or attracted. So, the essential problem in the trip distribution is to determine the number of interzonal or intrazonal trips from the estimated number of trips produced at and attracted to each zone. Trip distribution is the function of socio-economic characteristic of the population. Second, type and extent of transportation facilities. Third, pattern of land use including location and intensity. Say this is a area under study. So, some of the trips are going outside of this zone. So, this will be called interzonal trips. This is located in farm lines. So, this is called interzonal trip. Some of the trips are represented here in the dotted line. So, this is called intrazonal trip. Intrazonal trip. So, the dotted line will show intrazonal trip. Introduction, basic consideration of trip distribution. Input to trip distribution model. What are the parameters or input are to be given for the distribution model? So, here first is trip generation output. What are the output of trip generation? That will be the input for the trip distribution, means production and attraction for each zone. Second is socio-economic characteristic of the zone. Output are trip table, production zone to attraction zone. Separate trip table may be obtained by trip purpose. Introduction trip distribution matrices. Two types of matrices. One is production attraction matrices and second is origin destination, means OD matrices. The production attraction format of trip table should be converted into origin destination format to get a actual direction of trip between TAZS. So, this is a table of trip distribution matrices. We can see here, this is the attraction zone as we have discussed earlier. This is zone 1, 2, 3 to zone J, and this is the N, zone N, and this is the sum of all zones. In the right side we can see this is the production zone 1, 2, 3 to N, and this is the summation. So, as we have discussed earlier, this will be T11, means zone 1 to zone 1, production in zone 1 and attraction in zone 1. So, it will be T11 and so on. In zone J, the total number of attraction are T1J. 1 is the number of zone and attracted in zone J. So, in this way the total number of the zone 1 production will be equal to P1, and in this way all summation of all zones will be equal to T. In this way we can compute the matrices of trip distribution. So, thank you very much. Thank you.